Welcome to Abrar Electrical World channel. We are conducting a series on the power system stability types, disturbances, and what kind of studies we have to do. So, in 2 3 slides, we have already discussed what is the rotor angle, what is the effect, what is the total power which is delivered, which is given by the electrical power given by EV divided by x and sine delta. E is the sending end voltage and V is the receiving end voltage. In somewhere you can also find it written as P electrical is equal to ES EV over delta, sine delta and divided by x. So this is also you can find equation written somewhere in the books. So these are the same equations, and in this usually the resistance is taken as the cipher 0, no resistance at all. So this is the equation and this is the curve which shows the horizontal line, the mechanical line, and this parabola shows the electrical power delivered, which is maximum when sine delta is equal to 1, that is the delta rotor angle is 1. Now what happens when there is a disturbance? I had explained to you, and the disturbance is of such a nature which is known as a small or big. So small means the steady state limits, and the which I showed you in a different lecture, that maximum limit for the steady state is 90 degree, delta is 90 degree. Now here we are discussing that what is the frequency stability. So frequency stability means that frequency should remain in a certain range when the system is disturbed. That means that there is a heavy load rejection, either rejection or heavy load is coming on the system out of the below due to tripping somewhere else. You have a impulse of the loading on the generator. So what will happen when there is extra load on the generator and it is already running at a maximum level or close to maximum, and the extra power comes on the generator? What happens? The speed decreases because the mechanical output, which is controlled by the governors or the other valves, cannot increase the mechanical power instantaneously. It takes some time. Now when we say take some time, we are always talking here about milliseconds or 1 second or less or millisecond. So we are not talking in minutes. So the impact of the behavior is in milliseconds or just 1 second or 1.5 seconds, etc. So what happens when there is a change in the speed of the rotor of the alternator? Then with the increase or decrease of the speed, the frequency changes, because you know this formula, you have stated this formula, that speed is equal to 120 F over P, where P is the number of poles and F is the frequency. So it means that F or frequency is proportional to what? It is proportional to the speed. So it means that when there is an abnormality or a small or a large disturbance in the system, the frequency will go up or will go down according to the speed of the stator or speed of the alternator. Not stator, the rotor, or the speed of the alternator. So what happens? Again I will repeat, whenever the electrical loads is suddenly increased on the alternator due to any change of flow in the power system. Suppose there are 2 3 alternators are running in parallel, maybe at the same station or at different stations, and one of them trips due to some fault on the alternator. Now what happens? The load will shift to the other 2 alternators, and then there will be a instantaneous decrease in the speed of those alternators, and then ultimately they will pick up. If they pick up and take the load and the angle is settled down again, as I explained in the other lecture, then we say then the system is stable. But here we are talking about the frequency. That frequency also changes with the load rejection or sudden load increment on the alternator, and this is because due to this basic fundamental formula which you have studied in machine design in second or third semester of your engineering. So I always mention the formulas, differentiations, equations, just because that we are going to be engineer. So please don't be afraid of these equations. If you remember the equations, they will help you in understanding the problem very easily, as this parabola helps you understanding that mechanical power is constant and electrical power will increase. Mechanical power will increase after a certain time in a millisecond. So for that period, the rotor speed will go down and then the frequency will go down or frequency increase. Now, what is the limit of the frequency? Range of the frequency for which it is supposed to be stable, that is given into the standard, and for 50 cycle it is 1% plus minus. It means that 49.5 and 50.5. This is the range of the stability limit of the frequency. So we call it the frequency stable limit. This is the frequency stable limit. So similarly, we have the voltage stability limit. We will discuss in other lecture. Now here we are talking only about the frequency stability limit. So this is a kind of the stability, and this is known as the frequency stability limit. So the kind of stability will be the frequency stability, the voltage stability, and then angular stability. We will discuss them in separate lectures. And then ultimately we will go to the power swing and other phenomena, and as I told you, we will also discuss the behavior of the distance relay due to these changes, abrupt changes in the power system. Thank you very much. Please share our lecture. These are for the engineers and there is no commercial benefit out of it. Nobody looks in such a huge number that I will be paid by the YouTube for this channel. This is just a voluntary work for our junior engineers. Thank you very much.